Hello, class. Okay. Uh, we are back to continue our lectures. Okay, from last time. Okay. The screen that you are seeing. Okay. Uh, is updated one. Okay. We update. I did put some additional material here. Okay. On the folder called analysis cascade RL circuit here. Okay. I think that you all know the link to get into this channel of document uh, uh, folder. Okay. Let me review our last time. Let's say sorry. Uh, what from our last the lecture from the last clip. Okay. Okay. We start with this. One that we start with the basic RL circuit on one stage, okay, and then start expanding for the cascade of two stage, okay, just like what you show in the pictures, and now the three stage here, okay. Actually, the way we do is that we trying to find the corresponding differential equation uh, separately, independent of each other to the regular mesh analysis that we study from the circuit analysis course, okay. And once we try to expand the number of stages cascaded together, just like it was shown in the figure, we start seeing some what we call the pattern, okay, of the corresponding higher order linear differential equation. You can see that the terms start to become more complicated. Okay, and then from the last clip out from page 5, we start to developing some computational procedure, okay, systematic one, by assigning this C sub 1, C sub 2, okay. And the thing that we get here is that we can reduce the complexity of the form, okay, as the number of stages increase, cascaded stage increase, okay, and you can see that from when we start with the four stage cascaded IL circuit, okay, this is the corresponding form of the higher order differential equation is in the order 4 of I sub 1t. Okay, now we go to the 5 loop, 5 RL circuit cascaded together. Okay, this one we go to from the last clip, so I'm not going to go to again. And then again, we get the corresponding differential equation here. Okay, and I did give a homework on page 9 here that so far we've been trying to formulate the equation based on the system parameter. But in this one, we left you with a homework that suppose R sub 1, R sub 2, R sub, up to R sub 5, L sub 1, L sub 2, L sub 5. And we were giving ET is equal to 100 times sine t plus 50 cos t. With all necessary initial condition at 0, it means that we start the circuit by an open circuit having some switch on the voltage source ET, okay, and then once the switch turn on, okay, which means that you uh, short the circuit, okay, to make it a complete circuit. Then we would like to know, okay, what is the expected I sub 1t up to I sub 5t. And then we, let's say, derive the result in case of a 6 cascade RL circuit, which actually from the information last clip, okay, we already did that, okay, here. Okay, and we are using the systematic way of defining C sub 1 up to C sub 5, okay, in this case for to get the general form, and D sub 1, which is corresponding to the right hand side, to D sub 4, okay, and the last equation always gonna be C sub 5 I sub 1t equal to D sub 4 times ET. And with this appropriate substitution, you can rearrange the term as a 6th order ODE here. Okay, and from the last clip, we end up, okay, trying to generalize the formula that if we consider the end stage cascade RL circuit here, when you know this number stage become greater than 4, because 1, 2, 3 is quite the obvious result that you can use the direct method, okay, easily. And you can see that let's C sub j is equal to a star o 0j plus a star sub 1j plus a star 2 sub 2j times d square, okay, times d, okay, and so on up to a star j plus 1, okay, j times d to the j plus 1, okay, and with j equal 1 up to n minus 1, okay, and d sub k, okay, is just like this, okay, and k, you can see that k start with the have to be j minus 1, okay, so if j is so we not consider the c sub 1 here, we start with c sub 2 first, okay, you start having d sub 1, okay, when because j start with the 2, okay, okay, because in this case j start with the 2, not start with the 1. Okay, so in this case, the resulting equation is that you end up having a Cn sub n minus 1 times I sub 1 t equal to d sub n minus 2 e sub t. And you can have these two as an initial starting point, that C sub 1 and C sub 2. C sub 1 is a quadratic equation with operator d, okay, and with the system parameter as a coefficients, and C sub 2 also it become the cubic equation corresponding to operator d, okay, and with this and also d sub 1, okay, over here, okay, we can, okay, using this, okay, we start only d sub 1, okay, d sub 2, d sub 3, you have a general form of d sub k and c sub j, and with this computational procedure, okay, today we're going to show you that we can implement this methodologies, okay, on a platform we call the Microsoft Excel, which actually this file, I already put two files in Google Sheet form here. The first file is we call, and we already download here and put it in the Excel form over here. Okay, this is the first file we call computing coefficient characteristic equation. Okay, and the second file is this one, the computing coefficient characteristic complete form. Okay, we're gonna start with the first file first. Okay, with this one, because this one you can see that I put the results of R sub 1 up to R sub 5 and L sub 1 up to L sub 5. Based on the question that we asked you in this sheet. Okay, this is R sub 1 up to R sub 5, R sub 1 to L sub 5. Okay, and if we be able to put the formula here, okay, with C sub 1, C sub 2, and D sub 1, and using this recursive relationship, okay, that you can, it mean recursive mean that you can find C sub t based on C sub 2 or up to C sub 1, and also D sub 2. Once you know D sub 1, you can find D sub 2. Once you know D sub 2, you can find D sub 3 and D sub 1. D sub 1, D sub 2, you can find D sub 3. Once you find D sub 4, you only use D sub 3, D sub 4, D sub 2. Again, these two have a similar recursive form, so we can apply this and we can implement this for a given value of R sub 1, R sub 2, up to R sub n, whatever. But in that homework, we assign you with the 5 stages problem, okay. So today, okay, this is the continuation of the sheet that I prepared for you, okay. We're going to go back to the 5-stage RL circuit cascaded together, okay, just like what we show in this figure. You seen on the screen, Okay, this one I'm gonna put R sub 1, R sub 2 up to R sub 5, L sub 1, L sub 2, L sub 3 to with D as an operator of d by dt. Okay, and what you see here, okay, actually, uh, this is what we call uh, based on the formula here. Okay, the left hand side of the equation is c sub n minus 1 equal time I sub 1 t. Okay, so this is c sub n, uh, c sub 4. Let's just say this is c sub 4. Okay, how do I get this value, the numerical value here? Because with the given value of R sub 1, L sub 1, L sub 2, L sub 3 up to R sub 5, and L sub 1, L sub 2, L sub 3 up to L sub 5, if we go back to this formula, okay, if we implement it correctly, okay, you should be able to find C sub 4, and you should be able to find D sub 1 up to D sub 4, and put it in this form, and this is how the result is going to look like. But the key question is that how did I get this form? Let's start from the left hand side first. Okay, this is the left hand side, which is certainly is going to be 0.00000025 times d to the 5 plus 0.0008 times d to the 4, and so on up to plus 4, and altogether this term, the polynomial form of the order 5, okay, times I sub 1t equal to the left hand side. You know the left hand side have to be within order 4 because of the formula. This one is 0.00175 times d to the 4 plus 0.011 times d to the 3 plus 0.185 d to the 2 plus 1.1 d plus 2. Where do I get this? This have to be d sub n minus, in this case, the 5 stage, right? So d sub 3. So you can be able to find c sub 4 and d sub 3, okay, based on this formula. And you remember that the formula start with this. Once you know the R value, and then you use this substitution for the further stage, you should be able to end up getting this polynomial form. Okay, but how did I get this? Okay, so the first worksheet, okay, this is the one that we do. Actually, we use Excel platform, okay, to implement, okay, let's just say for this given value, R sub 1, R sub 2 equal to ohms. Okay, I put this on this 2 ohms, and then R sub 3, R sub 3, R sub 4, R sub 5 is equal to 1 ohms. Okay, this one, put it in here. And then L sub 1 to L sub 3, 0.1 Henry. Okay, this is the given value. And L sub 4 and L sub 5 is 0.05. Okay. So this is the one that I given you over here. Okay. And then how did I get this one? This is C sub 1, C sub 2. You find up to C sub 4 here. C sub 1 here, okay, is certainly E sub 4 times E4, the value in the cell E4 times E5, which is R sub 1. R sub 1 times R sub 2. Actually, this is coming from this formula. Okay. This is usually C sub 1 is the constant term is R sub 1 times R sub 2. And then the linear term, the coefficient that multiply the D term is L sub 1 times R2 plus L sub 1 times L1 plus L sub 2 times R1. Okay, and then the square is L sub 1 times L sub 2. So you can see that I just put this formula, okay, and make a link for this one. This one is R sub 1 times R sub 2. So for the easy one, okay, okay, let's do a sub 2 here. A sub 2 is G sub 4. This is L sub 1 times L sub 2. Okay, and for this one, okay, well, we may increase the scale a little bit so you can, so I have to get out first. Okay, what? It's not coming out yet. Okay, okay, I'm gonna increase the cell a little bit so that you can see the formula clearly. Okay, this one, okay, A4 times E5, this is R sub 1 times R sub 2, and this one, G4 times T5. This is L sub 1 times L sub 2. What about A1 here? This one. G4 times E4. G4, okay. L sub 1 times R sub 1. Okay. And G4 times E5 is L sub 1 times R sub 2. And G5 times E4 is L sub 2 times R sub 1, which is based on this formula, right? L sub 1 times R sub 2, L sub 1 times R sub 1, and L sub 2 times R sub 1. So this is just put this formula in this Excel form. Okay. The same for C2. Okay. C2, this one become, the first term become R sub 1, R1 times R2 times R3, this three value, right? And then as you know that the last term over here, okay, this got to be G4, G5, G6, okay, have to be here. G4, L1, times L2 times L3. And then along the way, okay, you get this one, okay. This one is a little bit complicated because G5 plus G6 times E4 and G4 plus G5 and then the last one G4 times E5 times E4. Where did I get this? Okay, it's coming from this formula, right? This one C2. You have 5 terms over here. Okay, 5 terms. You can see that once you get R1 times R2, okay, you get this L2 plus L3. Let's look at the formula. R1 times R2 is what? R1 times 2 is G4 plus G5, right? You go here. G4 plus G5. No, L1 plus L2. Oh, so we arranged it in the wrong term here. Let's look at here, okay? For common one, yeah. I think we did correctly, okay? So you can see that, so E4 times E5 is R1 times R2, right? E4 times E5, yeah, E4 times R1 times R2. Time what? G5 plus G6 is L2 plus L3, right? G5, G6 is L2 plus L3. You go back and take a look at the formula, right? R1, R2, okay, this one R1, R2, okay, you can see that R1, R2 times L2 plus L3 is this form, okay, and certainly you can have R1, R3 here, okay, these two, R1, R3. I think this one is a mistake, right? It should be because I made a wrong from the last one. It should not have the repeated form. It should be L1 times R2. This one not R sub 1 R2. Okay, you might go back to the original one. This one is the correct one. Should be this. Yeah, this one L1 times R2 times R3. Okay, so this and then as you can see from last time that there's some error, okay, along the way. So in this one, okay, so this one, okay, this one should be L1 times R2 on again. Maybe, sorry for you go to this one, go to page 15 over here, and this one, okay, this one should be L1 times R2 times R3. Okay, so when you R2 plus R2 times R3, okay, that's the only unique term, time L1, right? So you can look at the formula here, okay, it belongs to the last term, right? Because the last term is E4 times E5 times E6, which is R2 times R3, times G4, which is time L1, okay, L1 over here. And then the remaining two terms here is G4 plus G5, E4 times E6 should be, this one is R1 times R3, okay, R1 times R3, and then the 31 term multiplied by L1, the other term multiplied by L2, okay, and that's coming to this 2, right? When you have R1, R3, this term is R2. This is the last term. You have the other one, you have R1, R3 over here. You see that? R1, R3, here, these two terms. You get one time L1, the other one time L2. This leads you to this one, G4 plus G5 times E4 times E6. Okay, so this, I put the formula here to compute, okay, what we call C1 and C2, okay. But as you know that you can update C3, okay, based on this formula. C3 is A4 times C2 minus B3 squared C1, okay, and C4 over here. And then we already did some explanation here in this form. If you remember last time, okay, this one, okay. Once you know C1, C2, this one also, okay, this one L sub 1 times R sub 2 times, this is not R sub 1, should be R sub 2, okay. And C sub 3 here, okay, is A sub 4 times C2 minus B3 squared C1. So we put this formula because we already know C2 as a cubic function. Okay, you just replace A sub 4. A sub 4 would be R sub 4 plus D times L sub 3 plus L sub 4. And then we rearrange the term, you're gonna get the new one here. So this is the formula here. Okay, to get the constant term and the term linear term, the quadratic term, cubic term, and the quartic term over here for this quartic equation. Okay, or polynomial order 4. Okay, so with this update of the C value, okay, we can easily use this Excel platform, okay, to update this. Okay, we're gonna show you just some example like this one. Okay, you get R sub 4 times A sub O2. Okay, AO2, and you know AO2 is R1, R2, R3. So this one should have to be R1 times R2 times R3 times R4. Okay, and that's definitely here. Okay, so this one is you can see that we use this R4. This is AO2. Oh no, we consider here this term C3 here. C3 will be this one. This is the first row is that AO1, A1, A11 and A21. The second row become AO2, A12 and A22 and A32. This one with AO, I forgot the star notation over here based on what we say in the lecture. This one E7, the element refer to E7 is going to be R4, okay, time K5. K5, you know this value is R1 time R2 time R3. So actually this one we just use, okay, term by term over here, okay, with the Excel function, okay, to update, okay, according to this formula, okay, and we can continue to do it for the D value also. Okay, you start with D1 over here, and then you get D2 over here, okay, based on and instead of having this long term, you can reduce this, okay, and then use this formula instead. You can see that this is the same as it here, but to write down in this one is too long, and to what do you call redundant computation, okay. Once the D index have been increased, so we can update the D sub 2 based on D sub 1, and then D sub 3 based on D sub 2 and D sub 1, and so on. Okay, so this one we also did with the D parameter over here. Okay, we start with D sub 1 for given value according to the formula, and then okay, the same as what we did, and then for D sub 2 here we start to updating, okay, according to the formula here, okay, not this one, okay, not this one, but this one, Okay, the latter one here. Okay, and you can see that we already, once we put this formula in, okay, we should be able to, okay, with this file first, okay, and then we actually what I did is just make a copy to get this value, okay. This is the formula first, and to update for the C4 here, okay, it's quite very easy, because this one, okay, the last one, we just make a copy here to row by row to this row, okay, and then put on the update the formula here to here. Just for example, in this one, you get G6 plus G7 times N5 over here. N5 is over here. Minus G6 square. Actually, this where is this coming from? It's coming from this the with this formula that you get with the update formula. Okay, of over here. Okay, you can see that you have B3 square over here, B4 square. This is a square term that had an effect on the formula down here. Okay, so this one is just reference G6 plus G7 times N5 is over here, and minus G6 square. G6 square is this one is L3 square. Okay, okay, and time M4. This one go back. So with the same relative location here. Okay, as I told you before, to get the formula here, okay, it's very easy. I just make a copy down here. Okay, I can do it again to show you. Okay, it's gonna get, this is, so once I put the formula here once, I do not have to rewrite any formula here. I make a copy here. But for this one, we look at this. Suppose this is G6 by G7. This one, this new term is G7 plus G8. So suppose this is N5, it become O6, and this is M4, it's become N5. Move, you can see that with these two references, it moved to these two references. So you can see this is what they did. You can see this two, G7 plus G8, O6 minus G7 square times N5. This is reference to here. Here is at G6 plus G7. Okay. So this one becomes G7 plus G8. This one multiply O6. This one, because this one multiply N5. N5 is here. O6 is here. Okay. So just move this relative location of the data. Okay. Row by row like this. And this one time M4 over here. This one have to time N5. Okay. So this is the formula here. Okay. So, but this is just what we get here, okay? And if we be able to do in the Excel form, okay, if we follow this idea of the updating C sub n minus 1 and D sub n minus 2 when n increase, okay? So it will become very easy here once this platform has been developed. For example, I can, if I continue to another stage, I want to find C sub 5 here. Okay, what I did is I make a copy here. Okay, so this again. Okay, this one also. So sorry. So I make the copy of all this. Okay. Yeah, so this one we get C sub 5. Oh, sorry. I have something wrong with the data. Oh, it's wrong because I didn't put R sub 6 and L sub 6 first. Okay, so we cannot do it now at this moment. Okay, so we have to clear the formula first until we add R sub 6 and L sub 6 here. Okay, but this one it end here. And also with the same formula, we'll be able to find, once you get D sub 1, okay, you can see that to update this location, we look at this. This one is G sub 4 comes G sub 5, G sub 4, G6, G. So with this term over here, you just move to the next one. Okay, you can see that become G6. Oh, sorry. This is the first row that you develop the formula, because but this one is d sub 1 is you put it in according to this formula. Okay, d sub 1 here. Okay, d sub 1 is according to the formula in on page 14 over here. Okay, and then okay, for d sub 2 here, okay, you start using this formula uh, over here. You start using d sub 2 here. And to explain in more detail, you go back to sheet 9. Okay, yeah, you get d sub 3 here. You might say have to be before that. Okay, you get once you have d sub 1 here. Okay, to get d sub 2. Okay, to get you get this formula. Okay, so I just put this formula, okay, in the Excel of this. Okay, like this one, G6 for G7, and also oh sorry, it's missed. Okay, and also to get d sub 3 here. Okay, what it's easy to do. What I did is that I just make a copy of this formula. Oh, sorry, why is it changed? It shouldn't be. Something wrong. Oh, okay, you might take a look at it. This one E7 times K17. This one we E8 times 18. Okay, this one's a little bit different. Okay, this one G7 G8, and this one is a little bit different, G6, and yeah, this one is G6 G7 G. Okay, the difference is the start from these two terms. Okay, why? Because actually for D2 is and the formula start with D3 that you can apply the copy zone. Because if you look back at the formula down here, okay, uh, I just show you here. You see, d sub 1 is still minus b squared. Okay, this one. But once you get d sub 2 here, okay, mm, okay, d sub 2 here. D sub 2 is still in this formula, okay. But to get d sub 3, okay, the formula is not cannot be used as a d sub 3 because of the difference of the term, because a d sub 2 is a sub 4 d sub 1 minus b square b3 square times a sub 2, because they don't have d sub 0 here. Okay, comparing to what we call the general formula here. Okay, if you go move to the 5 stage here. Okay, you move to the 5 stage here. Certainly d sub 2 still the same, but d sub 3 you start having d sub 2 times d sub 1, and then when you go to d sub 4, okay, in this case, okay, you can see d sub 4 become d sub 3 and d sub 2, d sub 2, d sub 1, you see. So with the first one, d sub 2, the difference is that, so to find d sub 3 based on d sub 2, you cannot make a copy from d sub 2 up to d sub 3 immediately because of the difference here. But once you make from d sub 3, okay, is now it become the formula, because d2, d1, this one be d1, d2, d3. So that's why we cannot make a copy, okay, for this row. The difference will be here and here. Okay, but don't worry that I already make a correct formulation for you down here. Yeah, but the first three terms, this one is quite just a copy term. But start from the cubic term, okay, the start after the quadratic term, the cubic term and the quartic term here. Okay, but the formula here still you can see that it's not quite the same, right? This one for d sub 2, you cannot use this for d sub 3. Okay, so this one become just this one become the one that if you want to find these four, you can make a copy here and then use this as a starting point and then move row and columns, okay, by one position based on the formula here, put it in here. Okay, that we're gonna do it later because I already did you this file. Okay, the second file that we in this one I just put all complete here. If you keep continuing up to the 12th loop of cascade for this given value of L, okay, with this formula, okay, we can continue computing this up to the C11 because if you want to complete all the 12 loops, you need C11 and then you need D sub 10 over here. Okay, so it's already complete computing for you here. But just want to explain to you that actually all of this, okay, I cannot do all of this without the development of the last lecture from here. Okay, especially when we reach this point, okay, then get the resulting equation here. Okay, so those two Excel files just implementation of what we did uh, develop, okay, last on the last script, okay, resulting to this mathematics equation setup. And then, okay, now this is now you know already, right? How this equation coming out. So if I say that, okay, if I have this one is you have 5 stages here, okay, where n is equal to 5, you need to find c sub 4 times I sub 1t equal to d sub 3 times et. And what is the value of c sub? Okay, so we go move to this file, you get. So this one is c sub 4, okay, the coefficient, and this one is d sub 3, okay. So this one is for c sub 4 become the fifth order, okay, polynomial. So this one is 0.0025 and multiply d is at d to the 5 plus 0.0075 d to the 4. This is a4 for the coefficient for the fourth order term, okay, and 0.335 times d to the 3 and then plus 0.46 d square plus 2.4 times d and plus 4. Okay, from on the reverse reading from right to left, okay, coefficient by coefficient, you get this results. Okay, 0.05 d to the 5, a5 here, a4, a3, a2, a1, and a0. And all this, okay, according to the time I1t, okay, this one I1. Okay, on the left hand side, okay, you get d sub n minus 2, which is d sub 3. And d sub 3 you already find here, okay, in this one. I find d. So it will be 0.00175 d to the 4 times d plus 0.011 d to the 3 plus 0.185 d squared plus 1.1 times d plus 2. Okay, and all of this times et. Okay, and that's how this results coming out. Okay, the left hand side is this 0.075, 0.011, 0.185, 1 plus 1.1b plus 2. Okay, all this all to this fourth order polynomial term multiplied by et. You can see now, okay, how this equation come up with setup, coming up with this relationship, and then with this Excel, okay, substitution of the given parameters. Okay, you get c sub 4 here, and then you get uh, d sub 3 here. So just use this coefficient and then multiply by d according to the corresponding order. Okay, you get the results over here. And now, okay, we're going to solve this differential equation by going back, okay, to the old stuff that we studied from the very first class of ordinary differential equation. That okay, this one you once you know et, okay, you can okay, which is this, in this example we have given this et for you, okay, and then you put et to the right hand side and then passing through this operator d, okay, fourth order polynomial operator d, you get the right hand side function. And then you can say that, okay, to find I sub 1t, okay, based on the concept of solving ordinary differential equation, I sub 1t need to have two components. The first component of I sub 1t we call I sub 1 superscript ct. C is coming from what we call complementary solution. And then the other term is I sub 1 superscript p of t, okay, domain t. P is coming from abbreviated from particular solution. Okay, so to find, if you might remember that to solve differential equation, first you have two type of equation. Okay, the one is the particular solution and the other one is complementary solution. To find the complementary solution, okay, you need to find what we call the root of polynomial, okay, by considering replacing the d by s, okay, okay, just a variable called s, okay. Now, okay, because d is an by dv, s become a variable that you want to solve for the root of polynomial. Why you want to find this root of polynomial? Because I sub 1 sub c of domain t, okay, is to find the response of I sub 1 t, okay, when, okay, you have no uh, let's say you have no input for the right hand side, which means when et is not considered or equal to 0. Okay, so when you start considering, you consider what we call the characteristic, or sometimes we call auxiliary equation of this polynomial order term, okay, which is gonna follow what the order of the your differential equation is. In this case, okay, it's very easy, okay, just replace d by s, you have a fifth order polynomial. Therefore, there exists 5 root of polynomial here. The possible 5 value of s here. And you can see that I already find it for you, this one. It become all real number, minus 3.24206, minus 6 point, okay, this one. Minus, oh, okay, we try to do it again. Okay, okay, here. Oh, again, what's wrong with me? Okay, okay, okay. Oh, why? Okay, sorry. Okay, wait. Okay. Okay. Where do I get this all possible 5 root of polynomial? It becomes distinct root between this unequal value and all are negative. Okay. Because if you might recall from your basic already differential equation, you can see that you end up having a general form, okay, of I1ct in this form. C, a constant c sub 1, okay, time e to the s sub 1. Don't confuse this c sub 1. I'm very sorry, c sub 1 up to c sub 5 to this one, to the original here, okay. It's the same notation but different meaning. Because why do I repeat using this? Because we already applied this, okay, first place. Once we apply this is C sub 1, C sub 2, C sub 5 according to this computational procedure to find this coefficients value. Once this coefficient find, okay, this is another form. Okay, I normally use this for because of the popular notation. Okay, when you study ODE. I sub 1 complementary solution of domain T become C sub 1 times e to the s sub 1t plus c sub 2 times e to the s sub 2t and so on up to c sub 5 times e sub 5 times t. Okay, this is a distinct root, okay, but you know that there's many possibility. It can be some repeated root, which rarely happen. And the third case is that you might have some complex conjugate. Okay, if you have some complex conjugate, the general solution of I sub 1 sub c t, okay, will be a little bit different. They will have some exponential term times sine cos term. Okay, but in this case, we only have all 5 distinct root. Okay, and this is a general form for I1 sub ct. Okay, and the key question is that how do I get this root? How do I solve this? Is it possible that I need to solve this? Okay. Okay. We can do it. Okay. With this, but I should have write it down first. But we can do it by there's some available. Okay. For to find the root of polynomial online. Okay. You go to the Google search, just like what you are seeing on your screen now. Okay. There's many website here. But the one that I'm going to recommend you will be this one, the what we call over here, equation solver, Wolfram Alpha. Okay, so I'm going to enter here, Wolfram Alpha. Okay, and this one, equation solver. Okay, so I need to, take some time for me to write down the equation. Oh my God, I didn't prepare the pen. Okay. So I'm gonna write down the coefficient first, okay? Oh, okay. We just look now and then we go back after. So you get this right, 0.0005025, okay? Okay, and we going back here. No, here. We go here, okay. I'm gonna push backspace. Okay, we start having this equation. The first equation is 0.50 and then 25, and then you can say that your variable that you want to find the root you call x instead, and then you put this sign of the power. The you can see it's a shift, and then you press the the number 6, okay, on the major screen. Okay, you end up having this one, having this exponent. Okay, and this one is exponent is is 5. You put 5, and then you put the scroll down here to make it come back to the normal uh, normal horizontal line of input. Okay, plus, okay, what is the x to the 4? X to the 4 here is 0.0008. Okay, you get plus 0.008. Okay, you get time x. Okay, mod to the 4. Okay, come back to normal, and then plus. Okay, so you can see that 3, sorry, the 30 here. Okay, of 8, 30 of 8, and then you get this one. Okay, 0.0335. Okay, s to the 3. Okay, the reason I use s in the lecture was because that's the normal notation that you familiar from the differential equation. But to find the root of polynomial, normally we use x. Okay, again, I forgot this one. You get 0.0335. Okay, this one you get 0.0335. Okay, time x to 3. Okay, coming back here, plus this one is 0.46. Okay, 0.46. Okay, time x to the 2. Okay, and then plus, okay, and 2.4x plus 4. Okay, you get 2.4x plus 4, and I say is equation equal to 0. So this is the polynomial order 5. Okay, and you want to find the root, all possible 5 root. and I just gonna press enter. Okay. Okay, Wolfram Alpha start computing online for me. Okay, and now you get the solution here. Okay. And this is all the 5 root here. Minus 3 from the largest, smallest to the largest. Okay, the largest is minus 3.24206. Okay, which is this one, minus 3.24206, and then the next largest one is minus 6.31996, which is here, 6.31996, and then minus 10.949, this one. Next one to be minus 26.086, 26.086, and then S of 5 is minus 273.43, minus 273.43. Okay, so you can see that you can find all root of polynomial, just put it in here using the Wolfram alpha. Actually, there's many, I didn't try it all, but this is a famous one. Okay, Wolfram is a company that built a software, what we call Mathematica. And when you see alpha sign here, they say computational intelligence. Alpha is a couple of years ago, they developed an AI system that can beat Go or champion. Okay, Go is the game, the Chinese game. Okay, that well-known one. Okay, and okay, so this, now I already explained you how this all 5 root coming out, and once you know this 5 root, you can put it in the exponent term for the ICT. And you can see that with all the negative value of the root of this polynomial characteristic equation, you will know exactly that as times pass or t approach, if you take the limit t approaching to infinity, doesn't matter what the value c sub 1, c sub 2, up to c sub 5 here going to be, I sub 1 ct have to be approaching 0, which in engineering sense we call this a transient solution, which means that as I told you before, it's the effect of the system responds to when there's no effect from the input source, which is the voltage source over here. Okay, it means that the system will have this response, okay, temporary. Okay, but as time goes by, I1 sub c at the domain t will be approaching 0. Okay, just like if you compare, if I put the ammeters, okay, for to connect it with I1 here and to monitor I1t here, okay, you might see that but when you look at the digital meter, you can see that once you make a measurement, the resulting gonna hang out for a while, gonna be it's not gonna say that okay, this is the value. It's gonna take some time before it stop and show you the exact value. The time between, okay, they finding tuning to get the exact value is this one, is this I1 CT, because eventually when all that effect gone, that's why we call transient solution, which means that it's going to stay for a while, but toward the end, some steady state solution that will be consist only I1PT, because I1PT will consider particular solution, will consider the effect from the voltage input source directly. Okay, so this is the general formula, okay, for I1CT. Now, the remaining part of I1CT is that how do you get C sub 1, C sub 2, C sub 3, C sub 4, C sub 5 numerically, which you cannot find it here, but now you can find what is the S sub 1, S sub 2, S sub 3, S sub 4, and S sub 5, okay, as I show you that from this root of polynomial. And then you get this form. But to find C sub 1 up to C sub 5, you need to find I sub 1 PT first, and then combine these two terms together and use what we call the initial condition. That's why the question that we asked you previously on the exam question here, okay, they say that all necessary initial conditions are 0. This initial condition had an effect what we call
to here that to help you to find c sub 1 up to c sub 5 numerically. But before that, at this stage, you know the general formula of I sub 1 ct, and you know the exponent term, okay, the coefficient on the exponent term that multiply by the domain t. Okay, so for the second stage here, okay, this is what we need to do is that we are looking for to find what we call the I1 superscript P of domain T. I1 PT normally rely directly to what the right hand side or what the voltage source look like. Okay, in this case, ET is 100 sine times sine t plus 50 cos t. You might not remember, it was mentioned here. ET is over here. Okay, so now we move here. So with this form of ET, okay, is an amplitude times sine, okay, t plus 50 cos 2t, okay. So in general, I1 PT will be in the form similar to what ET look like. But you need to cover all possible cases, which means that if they have sine t, they have both sine and cos t, okay. So this one is the term, once you consider ET have a sine t component, therefore particular solution of I1t as a response, you need to have a constant value, the amplitude of sine t times sine t plus another amplitude times cos t. Okay. Again, it's an additive form. Therefore, with ET have another addition source of cos t, but cos 2t, 2 times t. So with this one, lead you to another two form of another amplitude of c times sine 2t plus amplitude of d times cos 2t. You might wonder why the IPT not consider have to consider cos, or this one have to consider sine, both cos and sine. Even the ET have only sine and cos because of the differential equation. Your left hand side is a differential equation. Once you have a differential equation, you look at the effect over here. The input equation that you put here, the left hand side you have a fifth order. And all this fifth order you need to have the derivative of I sub 1t. Now you consider the effect of particular solution of I1t, or so you might call this a steady state solution. Okay, I1t here. So you know that I1t, okay, can be multiplied by 4, it's just a constant. But when multiplied by 2.4 times d, you find the derivative of I1t. And second derivative, third derivative, fourth derivative, and 5 to 5 derivative. That's what you have to do here, okay. You can see that when you find another higher order derivative up to the highest the order of the left hand side equation, you know that sine become cos when you make a derivative, and you make a derivative again, cos becomes sine. So that's why you need, when you find even though you find the right hand side only sine t, you need to consider the left hand side both sine and cos t. Because the left hand side, if you contain derivative term, once you make a derivative, of course, become a sine. So when it becomes a sine, it's similar to the right hand side. Okay, the same as cos t. Even the right hand side only contain cos t. The left hand side once it, if you consider only cos t, if you don't consider sine t, remember that with the d operator of the differentiation, this sine t becomes cos 2t. So what we did, we are using to find I1 superscript T of domain T. We just use what we call the classic formula of we comparing the left hand side and right hand side coefficient. Now the what we call the right hand side coefficient, okay, of sine t is 100, of cos t is 0, of cos 2t is 50, of sine 2t is 0. But the left hand side, okay, you need to find what is the A, B, C, D, okay, because once the left hand side, if you put this form in this form of sine cos, okay, if it did pass through all of this derivative term, it's gonna contain only the term of sine t and cos 2t also. So what you did is that that's a common term. So you just make coefficient comparison from left hand side and the right hand side because it must be equal. So the coefficient that multiply sine t on the left hand side have to be equal to the coefficient that multiply sine t on the right hand side, on both right hand side and left hand side. And the same for cos 2t. So that's why we need to find the derivative of phi 1. You see that a sine, dip sine become cos, dip cos become minus sine, sine become cos, and then you have to, since you have 2t here, you need to find the derivative inside sine term. You get the d2t by dt, you get another 2 multiply outside here. And this one d cos 2t become minus 2d sine 2t. So this is the basic derivative, okay, that you should know. And then once you make a second order term, cos become minus sine, sine become cos, and then cos become minus sine, and then sine become cos, and the coefficient is 2c, 2d become 4c and 4d. Because with cos 2t and sine 2t, once you find the derivative, you always have a term of 2 multiplied with the previous term. Okay, so the third order become, this one sine become cos, cos becomes minus cos becomes sine, and then sine become cos. Okay, no sine change, but 4 change to 5. No, so change to 2 times more to becomes 8. This the same is minus, but this one minus cos become plus sine. And then the fourth order, cos become minus cos becomes sine, sine become cos. Almost reach the loop for the first order here. But the difference is that the cos 2t, the coefficient keep increasing in the 2 times because of the cos 2t and sine 2t. Okay, and now the fifth order over here. And then this is what I did. The fifth term over here, what you need to do, you need to multiply by a star 5, 4. This one, the left hand side here. And a star 5, 4, a star 4, 4, a star 3, 4, a star 2, 4, a star 1, 4, and a star 0, 4. Where is it? This one. The one that we identify here on the left hand side. Where do I get this one? It's from the Excel file over here. This one. Okay? And then you get this one. The D will be used later, but this one just for the C. Okay, so this one is the left hand side. And you know that the right hand side, we also have, you cannot compare ET directly because ET, you need to pass to fourth order derivative, third order, second order, first order, and zero order. So the same as the right hand side, you need to find the derivative up to the fourth order of ET. But this one is a little bit easier because you only have sine term and cos term. So you again, the first CCT is here. dEt by dt can be 100 cos t plus, this one is instead of you dip, you find the derivative of cos become minus sine, and then 50 become 2 times more, okay, become 100, and 5 second derivatives 100 become 200, sine become the no sine change, okay, cos, but this one you find the derivative of cos, this one become minus sine. The third order, the same, the first term is the same, just as because the derivative of sine, you get cos, just change sine to cos. This one from minus 200 become plus 400 because you find derivative of cos, you get minus sine, minus times minus become plus. Okay, this is the fourth order, derivative of minus cos become plus sine, 100 sine. And then coming back to just like what you see in the zero order term, but for the, except that for the cos t, instead of you have 50, you become 800 because you always multiply 2. Okay, for 50 to 100, 100 by 200, 200, 400, 400 to 800. So now once you know here, what is each term of this one, multiply for the left hand side, become here. And the zero order become B star 0, 3, B star 1, 3, B star 2, 3, B star 4, 3, and B star 3, 3. Okay, this one is the coefficient over here. So we can make a what we call the coefficient comparison. Okay, from here, the right hand side, this is the right hand side. I arrange the term, put all the term that multiply sine t all together, put all the term that multiply cos t together, and put all the term multiply sine times 2t together, and put all the term multiply cos 2t together. This is the right hand side. Rely on the b coefficient. What is the result of this b coefficient? I'm not going to compute the value for you. It's already here. Okay. And what is the left hand side? This is, I just change the term, the left hand side, the term that multiply the a components. Okay, the term that, this is the term that multiply with the what we call the sine component, sine t. Okay, for the left hand side over here, this one. I already did this. Okay, because once you get this, you rearrange the term the left hand side over here. Okay, by combining just the term that multiply to the sine t, we get this form. You leave the value of a and b, and you know that a star 0 4, a star 1 4, 2 4 up to a star 5 4. What is the value here? You already know the value here. We already identify here. So all this can be substitute. Okay, this is a star and b star. And what you get is that once you make a coefficient comparison, you get the equation of 2 by 2. Okay, two problem. One to find a and b. As I told you, if you put down the value of a star 0 4 up to a star 5 4, and this one from b star 0 b star 0 3 up to b star 4 3. Okay, all this will be the numerical value. This is a coefficient multiplied by a and coefficient multiplied by b on both equation. So it becomes a very easy equation, a 2 by 2 equation. I think that with the tool that you study from, you should find a tool to find a and b for you. The same of c and d. Okay, this one you end up having two equations if you substitute a star to 0 4 to a star 5 4 and b star 0 3 to b star 4 3, you get to find c and d. Once you know the numerical value of c, a, b, c, d, now you completed the form of I1t. So I1t becomes c. You remember the c sub 1 up to c sub 5, you still haven't found it yet, but you know the value s sub 1, s sub 2, s sub 3, s sub 4, s sub 5. And now you, with this, you can find the value of a, b, c, and d. Okay, so to find c sub 1, c sub 2, c sub 3, c sub 4, c sub 5. Okay, therefore you need 5 initial conditions. You already know that I sub 1 is 0 is 0. You put the first derivative of I sub 1 at time 0 equal to second derivative. You only reach only 4 derivative because you need 5 conditions to find constant, 5 constant here. All this necessary condition equal to 0. Okay, so you just make, you have to make, you can see that you just know this formula, you just find the derivative up to the fourth order and substitute t equal to 0. You end up having a system of equation, okay, of containing c sub 1 up to c sub 5. Okay, and that's what we are doing here in the next slide. The resulting equation will be here. Why? Let's look at the obvious one. So I1 at t equal to 0. Okay, you get here c e to the 0 when t is equal to 0. So when e with the exponent of 0 always equal to 1. So all this term becomes c sub 1 plus c sub 2, c sub 3, c sub 4, c sub 5. And you know that sine 0 is 0, so there's no a term. But cos 0 is 1, you get b. And sine 2t, sine 0 is 0. The cos 0 is 1, you get b plus. So you get c1 plus c2 plus ct, c plus c4 plus c5 plus d equal to 0. That's how you get here. The first equation. The second equation, how you get s1, s2, st multiply here? Easily from derivative of c sub 1 e to the s1t. Once you find the first derivative, you get c sub 1 times s sub 1 e to the with exponent s of 1t. The same for the second term up to the fifth term. And when you again when you substitute t equal to 0, the term exponent become 1 because e to the 0 is equal to 1. Okay, but you have to know that the this one change, right? Once you find the derivative here of a b, but to find this derivative, you already find it here, right? This is the first derivative. So from the first derivative, you know that a when you put t equal to 0, you get a. There's no b, there's no d because it multiplied by sine. Sine 0 is 0. So you on this one you get a plus 2c. So this one, this the result, the second term, s1, s2, s1, s2 is a find the resulting of finding the derivative, okay, that for the exponent derivative you get here, this one a plus 2c. So with all this similar form, okay, once you find the third derivative, another s1 multiply to the previous coefficient, another and s2 multiply coefficient. So the previous coefficient of s1 become s1 square, s2 square, s3 square, and so on up to the fifth equation. So the next one you multiply it, and when you get the multiply by at t equal to 0, you always get the exponent of 0, which is always equal to 1. So this one is a coefficient you find s of 1, s of 2, s of 3, s of 1, s of 2, s of 1 square, s of 1 the cubic of s of 1 3, s of 1 and the quartic term of s of 1, and so on for s of 2 and s of 3, s of 4 and s of 5. And this one a plus 2c minus b plus 14, where did it come from? Coming from here, right? The second order, okay, become minus b, this term become 1. Cos t become 1 at t equal to 0, minus b, and then minus 4d. Okay, that's how you get this minus altogether b plus 4d. Okay, for the next one, the third order, okay, you get minus a here, this one is 0 at t equal to 0, and then minus a minus ac. So this one minus a minus ac, you put the bracket on, become minus a plus all ac together. And the fifth term, okay, using this fourth order, you get b plus 60 plus 16d, okay, multiplied by cos d. And then if you move this, all this, you remember that a, b, c, d, you can find it here, right? By solving this equation, you should be able to find it. And then once you know this, okay, you put it in here. This is in the matrix form, okay. So you should be able, and you know all the s value, right? So the remaining is to find c sub 1 up to c sub 5. And you can find this as a numerical value. So you solve for c sub 1 up to c sub 5, and then you put all the value in this form. Now you have an exact, Now once you finish this process, you should be able to find I sub 1t in a complete form with all numerical resolved value of c sub 1 up to c sub 5, s sub 1 up to s sub 5, and then a, b, c, capital A, capital B, capital C, and capital D. Okay, with the remaining parameter of the which is the domain of the problem, the t. Okay, so that's just guide you an idea that you should be able to solve this problem now. Okay, and in the next step, okay, we'll talk about how to find what we call the remaining variable, okay, which is I sub 2t, I sub 3, I sub 4, up to I sub 5, okay. Remember that in this up to this point, we'll be able to find I sub 1t complete solution, okay, based on this given value. That's the previous homework, okay. But I show you all the process, which is the remaining part of finding A, B, C, D. I already find S of 1 up to S of 5 for you. Once you find A, B, C, D, you put it in this equation, okay, you should be able to find C sub 1 sub 2, C sub 5. and put it in this formula, you get I1t. Okay. To find I2, I3, I4, I5, you have to go back to the previous slide that we studied here. Okay, we have derived some of the very important formula here. Just like in this is an easy case, you can substitute it immediately, but you can start from here. Okay, for the fourth rule, you can see that this is I sub 2, 3, and this is I sub 3, 3. It doesn't matter if you increase the new cascade circuit, okay, to 4, 5, okay. The nice thing is that this equation still always hold. The previous one, except the last one that you're going to continue the equation here. Okay, so the previous one that you already analyzed is always whole. So we can use this, okay. There's this one, I sub 2t, okay, is equal to a1 I sub 1t minus et divided by b sub 1. With a sub 1 is here, r sub 1 plus dl sub 1, and then b sub 1 is, you can say that d times l sub 1. Okay, so I'm going to use this, okay, to help us to find I sub 2t. Okay, so this is the important one. Okay, I think we can recall some of the previous result that we have done here. Okay, this one, I recall this. Okay, the previous one, and we're gonna use some property that, since we already have d equal d by dt, but you know that b sub 1 is, in this case, is d times l sub 1. What is the meaning of 1 over d instead of d? Okay, if d is the derivative, the inversion of derivative is integration. Okay, so this is the basic calculus that you should know. Okay, the inverse of derivative is integration. And also the inverse of integration is derivative. Okay. Okay, back and forth. Okay, so you can see is that we can simplify this. Okay, this is what I'm going to do. Okay, so look at the first term here, r sub 1. If you only consider r sub 1 and then this one l sub 1, you r sub 1 minus l, you get I sub 1t minus r sub 1 divided by d l1. So this one is this term, since 1 over d is the integration. So the first term is r divided by r sub 1 divided by an integration of I sub 1t dt. And then the second term, you can see that d times l1 cancel each other. Okay, so the second term is only plus I sub 1t. And then minus, okay, this one is 1 over d l1, you can 1 over l1, but since d is the integration, this is integration of et dt. So now you get the formula to find. You already know what I sub 1t look like. You can find I sub 2t based on this substitution of this formula. By this substitution, okay, you already found that what is the integration of I sub 1t. You know I sub 1t is this form. As you know before previously, you find all of these necessary parameters, c sub 1 up to c sub 5, s sub 1 up to s sub 5, and a, capital B, capital C, capital D, in a numerical value based on the given value of r sub 1 up to r sub 5 and l sub 1 up to l sub 5. Okay, so now all this, so you should be able to find the integration here. Since this is a very easy integration, I'm going to use this. The first term is become c sub 1 divided by s sub 1 e to the s1t. Okay, because the second term become here up to the fifth term. And then this one, integration a sine become minus a cos, since your dip cos is equal to minus sine. Okay, so therefore integration sine, you get minus cos. Okay, and b cos become b sine, because once you make a derivative of sine, you get cos. And this one is become c divided by 2. Why divided by 2? Because you get sine 2t and cos 2t. Okay, it's something reverse. If you find derivative, it become the multiple. If you find the integration, become a divisor. Okay. Okay. Uh, so I'm not gonna go to this. This is a direct, simple integration. Okay, for term by term. So now you get this is the term of integration I1, which is this term, and you already know the I1 is here. This term. And integration of et dt. You just make an you know et is here. 100 plus 50, you get 100 sine t because minus 100 cos t because the derivative of cos is minus sine. Okay, and then this one is reduce 50 by half because of you change you find integral of cos 2t dt to get sine 2t dt. Okay, because you find derivative of sine, you get cos here. And then the next step is you need to combine the term, the coefficient term together. You can see that the main term is still the same, very similar to the original of I sub 1t. The thing change is that the coefficient they multiply each term. This one is for I sub 2t. Okay. Why you get 1 here? 1 is because of this term, I1t. So I1t also contains C1e S1t. And this is the coefficient of 1. But what do you get? R1 divided by L1 S1? Certainly coming from this term, right? Because integration here is C. You have coefficient of C sub 1 divided by S sub 1, but C sub 1e to the S sub 1t already move out here. So the remaining term is that this term you multiply by R sub 1 divided by S sub 1. But this one you have to divide it by L sub 1 times S sub 1. And similar, this coefficient similar to this one. Just change S sub 1 to S sub 2, S sub 3, S sub 4, and S sub 5. Okay, so to combine these two terms. Okay, but for the sine and cos term, okay, it's a little bit, you need to be, because the sine term and cos term contain in all three of this. In this case, in the particular solution, okay. The sine t, okay, you can see that you have this term, right? You have a here for this integration, okay. Oh, sorry. Oh, and then you get no, you have it here, it, you have a term here. That's why a term here. Okay, and but for e term, okay, since you have integration et, you don't have sine t term. Okay, so there's no sine t term in here, only cos and sine 2t. Okay, so only these two terms. The first term you have I1, which is a here. I1 themselves, you have a. And the integration of here, integration here, okay, you have the sine t, you have b, right? Multiplied by b. But this b, you need to multiply r1 divided by l1. b r1. This is a sine. Okay. For cos t, okay, for cos t, certainly you have b here. Certainly you have b in term of I1t. In term of integration I1t, integration I1t, you have cos t, you have minus a. And this minus a, you need to multiply R1 divided by L1. Okay, R1 divided. But this one, integration et, you have term of cos t. Okay, but this one is minus. Time minus become plus. It become 100 divided by L1. And then you need to plus here. But in this term, you get the minus sign for integration for cos. So this coefficient is 100 minus r. Since they have the same divisor of L1. Okay, so you can combine this term together, and then plus b is coming from here. So this is the coefficient for cos t. Similar for sine 2t. Okay, there are three terms. This two term is similar, and for cos 2t is similar to what sine t. Okay, so you can see that the form of each term by term is still the same. The change is the coefficient. This one for I sub 2t. Okay. I'm gonna in my sheet here. I'm gonna do one more for you for I sub 3t. So I sub 3t here. Okay. So you get this. Where I get this is C sub 1 I2t minus A sub 2 et divided by b1 b2. It's coming from the old formula that we did before. Over here, right? Here you have I2 here. This one I sub 3t is C sub 1 I sub 1t minus A sub 2 times et divided by b sub 1 and b sub 2. And I just put that formula again right here. Okay, for I sub 3t. And all divided by b sub 1 by b sub 2. But you know C sub 1 is it? This is a general form of C sub 1. What is the value of A star 0, 1, A star 1, 1, and A star 2, 1? This one from the Excel file here, right? This one is A star 2, 1, A star 1, 1, and A star 0, 1. We already find it, this for you, right? For this example. So you know all this coefficient. Okay, this one is C sub 1 multiplied by I1 equal to A2. What is the A2? A2 is R2 plus D times L2 plus LT together. Where did they get this from? From the original here. Right? This is A2. A2 is R2 plus D L1 plus L2. No, I think don't make any mistake here. Now we go back to yeah, it should be L1 plus L2. I already, but it was 2. Yeah, this one L1 plus L2. Okay. Okay, R2 plus here. This is A2. Okay. So you rearrange the term here again. Okay, and make sure that 1 over D is an integral. Okay, so this one will become double integral. So the first term is that you find the integration. This is the common divisor of the L1, L2 here. Okay, so the first term you get A star 0, 1. Okay, and 1 over D square become double integral. So you find the integral of I1t dt first, and then find the integration by dt again here for the first term multiplied by A01. For the first term, d, okay, become 1 over d since this one, okay, the divisor was reduced down by this cancellation, okay, of d divided by d square, okay. So you get A11 square, A11 star, same divisor, L1, L2. But this one only one integration of yt dt. And then this one, d square cancel each other, so you get A star 2, 1 divided by I1 2 times I1t. And for the term of et, okay, you get R2 divided by I1 A2. This one is the d square. So d square, you need to find double integral of et dt, and find this resulting function inside first, and then find the integral again dt. The last term is that plus d divided by d square become one integral, and you get this L1 plus L2 divided by I1 L2, because this one, okay, the coefficient, and this one you get d divided by d square, you get only one integral of et dt. Okay, so to rearrange this form, we can do something similar to what we previously done. You need to find it, right? This is the general form of it. And you find the integration of I1t is here. Okay, I'm not gonna go. I think that it is quite obvious that you can easily understand this, not too difficult. And this one integration of it. Okay, and how come this happened again and again? Okay, I'm gonna do. Okay. Uh, okay. So this one is you want to find integration of I1t dt. You get this. Okay, based on integration term method. And once you get this value, you want to find another integration, the double integration, the second integration of integration of I1 dt. So you integrate this function one more time. You get this C1 instead of C1 divided by S1 squared. This one becomes C2, C sub 2 divided by S sub 2 squared. This one C sub 3 divided by S sub 3 squared. C sub 4 divided by S sub 4 squared. C sub 5 divided by S sub 5 squared. And this one cos, okay. Find the integration, you get sine, okay, not change because this is another integration here. And sine become minus cos. And this one cos 2t becomes sine, and then c with additional is divided by 2 become divided by 4, this one divided by 4. So now you find all the element here for the left hand side. No, for here. Okay, for this term. Okay, for this three term. Okay, you find here, here, and here. This. And then you know the coefficient and multiply each of this. Okay. And again for ET, you instead you find ET. Okay. This is what we did. Okay. ET is here. You find integration ET dt previously. And you find integration again of integration ET dt. You get minus 100 cos t become minus 100 sin t. This one divide 25 become minus 25 by 2 cos 2t. Okay. And in this one, okay, you need to multiply this integration term multiplied by L1 plus L2 divided by L1 L2. And this term multiplied by minus R2 divided by L1 L2. Okay, so once you know this, okay, I already arranged this for you. Okay, you might uh, increase the one. Certainly going to be the same. C sub 1, E sub 1, C sub 2, C sub 3, C sub 4, E to the S sub 1 t up to E to the S sub 5 t. And then some additional term multiplied by psi t, additional term multiplied by cos and sine 2t and cos 2t. The term is longer, you need to rearrange more, but not that so much difficult. And you can get all this because you know the value S1, S2, you know the coefficient value, you know the all the characteristic equation root of S1 up to S5. And you already found A, B, C, D, and you know R2, L1, L2. So all this you can substitute it to become a numerical value. Okay. So this is a good example for you to move on for the next slide, which is to find, okay, I sub 4, okay. In this example, I refer you C sub 1 is here because where do I get this? Where do I get this C sub 1? You can easily confirm here, right? C sub 1 already substitute and already find it for you. And then you can now go on to C sub 2. Okay, now you know C sub 2 is here and D sub 1 is here. But why? Always refer to this results. Okay, this table first. Okay, D sub 1, C sub 2. Okay, refer to this. And then once you know that I sub 4t is C sub 2, I sub 1t minus D sub 1 et divided by B sub 1, B sub 2, B sub 3. So you just put C sub 2 here, D sub 1 here, rearrange the term. Similar to what we did with I sub 2 and I sub 3. You should get I sub 4t in general form. The same for I sub 5. I sub 5, we refer C sub t and D sub 2. Over here, you rearrange the term similarly. You should be able to find. And the general form, I already show you in here that it's going to be something look like this. Some like I sub 4t become 1 over 1. The divisor we get out for all term will be L sub 1 times L sub 2 times L sub 3. For I sub 1 I sub 5t, we got 1 over L sub 1 times L sub 4, L sub 3, L sub 4. But term by term is going to be like this. Actually, you might say this as this times C sub 1, C sub 2, C sub 3, C sub 4, C sub 5. Going to be something multiplied by e to the s1t up to e to the 1, 2, 3, 4, 5, s sub 1, s sub 2, s sub 3, s sub 4, s sub 5 as an exponent. And then something, if you read it, some constant value multiplied to sine t, some constant value multiplied cos t, and sine 2t and cos 2t. Okay, for both I sub 1. The same formula, but the different coefficient. And this coefficient can be substituted to get the numerical value. So that come up to this point, you should be able to finish this assignment completely. Okay, this assignment you should be able to finish completely. Okay, so in the next step here, okay, we're going to talk about our final exam. Okay, you better, after finishing this problem as a homework, okay, you can extend working on, go back and, know the reason how, this script is very important to show you all the computational procedure. But with this, all this computational procedure cannot be accomplished without the basic knowledge that we developed from the previous script. Okay, so this is the homework, and both homework and take home exam for your final. Okay. Okay. We go back. On the Excel file. Okay. The first file we already used here, but we talking about the second file. The second file is a computing coefficient characteristic complete. Complete is mean that I already extend the result here, and I show you before that. This is a problem that can go up to the 12th stage of RL circuit, which means that we only did halfway R1, but this one it can going on. You can go to the 6th loop, 7th loop, 8th loop, up to 12. And with the same computational procedure, I already did it for you here. I already did the coefficient calculation for you, all of this. So, and all necessarily C sub Cj and Dj over here. So, what I expect is that go back to the concept that we say to you, that the resulting equation for I sub 1t, always using this formula, C sub n, C and D, can be using from this table in all case up to 12. Okay, up to 12 in this case. We already done C4 and D3. Okay, C4 and D3. Okay, we haven't tried C5. C5 is for the 6 loop, 7 loop, 8 loop, 9 loop, 10 loop, 11 loop, and then we finish at 12 loop here. Okay, the same. Okay, one C11 for the 12 loop, and this one is for D up to D sub 10, because the index of D is always 1 behind C. Okay, subscript index, I mean. Okay, so you always end up, doesn't matter how many loops you can write down the and with this given data you can find I1, the corresponding different higher order differential equation. So what the remaining task that you can do is that with the given data, I already given you 12 stages. You can continue to do 6, 7, 8, 9. You finish 5 first, 6, 7, 9, 10, up to 12. Okay, repeating the same. And I add you more for you. First one, if ET is the same, it's 100 sin t plus 50 cos t. It doesn't matter how many loop and how many branches continue up to 12. The first case is ET is the same. The second case is ET is in the polynomial form. one nice thing is that you might go back to your basic ordinary differential equation and how to make a what we call the coefficient comparison. Okay, when instead of when right hand side is a sine cos function, but this one is in the polynomial for order 8 form. Okay, okay. We give you example that for 6-stage case, but mean that from the last previous term we have 5 stage, 5 IL connected together. We add one more 6. Okay, this is the resulting equation. You put c sub 5 I sub 1 t equal d sub 4 et. And then c sub 5 is what? Now you using this c sub 5 here. Okay, I have c sub 5. And d sub 4 is here. C sub 5. So I just put c sub 5 and d sub 4 over here. This is c sub 5 coefficients, okay? And d sub 4 here. And therefore, you know that I1 complementary t have to be in this form. Again, why? Because the characteristic equation here, which is the root of polynomial order 6. And how do I going to find root of polynomial order 6? I go back using something like Wolfram alpha. Actually, which I already done. You might recheck it again whether I did it correctly or not. Because you see that I already show you here that you have 6 distinct real root, okay, real value. Start, the first one should be minus here, minus 3.24 or minus sign, okay, this one not plus, should be minus 3.2414 and so on up to s of 6. You might check it, okay, put it in here and then practice how to use Wolfram alpha to find the root of polynomial order 6. So the root of polynomial have no meaning. You can keep going on up to 12. The 12 you get 12 root, okay. But again and again you can, once you know this, you can always find I sub 1t. And once you know I sub 1t from the previous example, you already find I2, I3, I4, I5 here. If you finish the homework first, you must be able to find I5. And if you continue for I6, okay, 6 loop or 6 stage in this problem, you're going to have to find one I sub 1 CT and then IPT. And you can do on both case also, which means that E sub t can be case 1, sinusoidal signal, or the polynomial order 8 exam. Or to challenge yourself, you might combine all this together, which means that it's going to be both 1 and 2 all together. 1 plus t minus t squared plus t to the 3 minus 3 to the 4 plus t to the 5 minus t to the 6 plus t to the 7 minus t to the 8 plus 100 sine t plus 50 cos t. Just combine these two input together. It can be the third case, the hybrid case, whatever. Okay. So you can, create many problems to work on and to show me. But you have to start with the example of 5. First, you need to find I sub 4t and then I sub 5t and substitute all necessary numerical value to get the exact results. Finish the 5-stage problem first and then start continuing to 6, 7, 8, 9, 10. And you might redo the 5-stage problem again with case 2 or case 3. So plenty of opportunity to work. Okay. I don't expect you to do all the case. So this is just the first one. Not all of this. The course not finished now. First of all, this is just a start. Okay. So now you have a remaining homework to finish, plus this one, the last page over here that give you the opportunity to do your take-home exam. That I will control the submission pass you to Google Classroom later. Okay, so the clip that I've given you today and the previous one is very important. You go back, understanding both clip, watch it again and again, okay, and start working on the problem that already using these two Excel file to help you and do as much as you can and make a submission within the due date that we'll assign to you later. Okay, and next time maybe another clips. Okay, and we might meet in class for one more time. Okay, well, based on appointment. Okay, we're gonna move on to we still stuck with this problem for the rest of the semester, but we're gonna the approach that we done so far is we call the classical approach. It's a mathematical way, the classic mathematics derivation to get the exact results. Okay, but you can see that as the problem become more complicated, and now we only consider what we call the initial value problem. We use the initial value at t equal to 0. Okay, sometimes differential equation have a different type of condition that make the problem become more complex. With all those put it in detail that we put on add to the problem. Sometimes this direction of derivation got stuck, have a limitation to find the exact formula. So we're gonna go move on to the using the what we call the approximation approach, okay, to solve this problem. Okay, you see that the approximation is look a little bit easier, and you know that you might wonder that why I didn't teach it in the first place. It cannot because approximation is not perfect. Okay, in mathematics you start with a perfect, even though it's not practical, but it's a perfect because perfect is the beauty of mathematics. Okay, so we leave you with this word. Okay, see you in the next next script later on. Thank you.